Dear all, in this short video, we'll be discussing the first lab program on machine learning. The algorithm is find S algorithm. What is S? We'll come to know by the end of this session. While reaching to the last part of this session, we'll be coming to know what is S. So problem statement goes like this. For a given set of training data, these example data set are stored in comma separated files, that is CSV file. So you need to implement and you need to demonstrate by applying the algorithm finders to output a description of a set of all hypotheses which are consistent with the training example. Let us take a small dataset called play swim or play tennis dataset. Sky, temperature, humidity, wind, water, forecast are the independent features or attributes. Enjoy sports is the target value. The target is also called concept. This concept depends on these six attributes. For example, you can enjoy sports if sky is sunny, temperature is warm, humidity is normal, wind is strong, water is warm, and forecast is not at all changing, same. But you can't swim, you can't enjoy sports if temperature is cold, sky is rainy, and humidity is high. Forecast is changing, so in such case you can't. That's why the concept depends on those independent values. That is what is called dependent variable. So these are the six attributes which gives output, that is the concept. If some instance X satisfies all constraints of hypothesis H, then H classifies X as positive example. We can denote that as H of X equal to 1. So these are all the instances: first instance, second instance, third instance, fourth instance. There will be hypothesis. We'll get an hypothesis if it matches. If it matches, either one-to-one matches or some parameter can be. If it matches, that is called the positive example. In these three cases, this is one positive example, this is a second positive example, and this third is a third positive example. Now, in this hypothesis, there are two different types. The one which is general, which don't care the values of the attributes, which are usually indicated with a question mark. Other one is the most specific hypothesis, which is having the value 0. Okay. The most general and most specific. This find test algorithm with respect to specificality. S stands for specificality. The algorithm goes like this. You will be initializing hypothesis to the most specific hypothesis, that is that many number of zeros. If there are six attributes, six zeros you have to put. That is the most specific instances. Then you will be visiting each and every instance of data set. For each positive training set, you will be having positive and negative. Like in our example, we have to visit this one and this one. You have to ignore the negative example. This does not affect it. Also, you have to ignore this negative example. You have to consider The concept which has got positive. So to visit each and everything. For each positive training examples, for each attribute. So once you visit this instance, you have to see each and every attribute, which is matching or no. Initially, all the attributes are zero. So 0 there and sky is sunny. So that 0 has to be replaced by sunny. Earlier temperature also 0. Now it is warm. That 0 has to be replaced by warm. Like that, we'll solve the problem later. For each constraint A in H satisfied by X, then do the thing. Else replace A by H by the next more general constraint that is satisfied by X. So you have to output it. So initialize H to specific, identify a positive example, check each and every attributes. Attribute value is equal to the hypothesis value. If so, go for the next. Otherwise, replace by question mark. Let us take this example. Sunny, warm, normal, strong, warm, same produces yes. Sunny, warm, high, humidity does not change. So this can be replaced by question mark. All three same. This ignore. Sunny, warm, high. See, temperature is not a problem. Even water is not a problem. Can be warm, can be cool. Even forecast is not a problem. So it is a variation. Initialize H2. Most specific cases. There are six attributes. Fill it with null value, zero value. Now, first training example, first instance will take that is x1. Sunny, warm, normal, strong, warm, and same. Forecast is same. What is normal like that? These are all the attributes. What are the attributes? Sky, temperature, humidity, wind, water, and forecast. We have taken this first example because this is a positive example. So observing the first training example, it is clear that hypothesis H is too specific. We have started with 0. None of constraint in H are satisfied by this example. So each is replaced by the next more general constraint. 0 has to be replaced by sunny. The second is also replaced by warm. Like that, you replace everything. Now our specific H now produces this case. So hypothesis H1 is sunny, warm, normal, strong, warm, and safe. We have changed most specific to little general one. We'll go for the second example. The variation is there. In the third attribute, that is humidity, there is a variation. This is a humidity attribute, there is a variation here. And all the things are same. And this is a positive example. The second training example forces the algorithm to further generalize H. This time, substituting question mark to the attribute where there is a change. The first attribute is same, second is same, third is different. So this you have to replace by question mark. Now H is now little general. Earlier it was too specific in H case. Then H1 you have changed that to little specific, little general. Now still general one because the third attribute does not affect whether you can play or no. Go for the third example. In the third example, this is a negative example. So you can't start play. As we have seen this negative example, you cannot make any changes in the hypothesis. Hypothesis remains as it is than as of the previous one. We'll go for the fourth example, which is a positive example. The parameters which change are indicated with the red color. Now there is a sun which is same capacities, warm same, Question mark, you can't do any changes. This parameter is also same strong. The cool, now the parameter was war, now changed to cool, so that also does not affect, so put by question mark. The last same is there, change to change, so that is also a different one. You put that with the question mark. We don't have any more constraints, so this is the last specific one or most general one. When the parameters, the first parameter, second parameter, fourth parameter, sunny, warm, strong for this data set, you can play. And this question mark does not affect it all. So if this is a ocean space, we have got four examples. In that, x is a positive example, x2 is a positive example, x4 is a positive example, and x3 is a negative example. This is the most specific case where all the attributes are zero. This is the most general case where all the attributes are question mark. H1 is that is obtained from the first set, this one, because H was zero initially. All the attributes are zero initially. Now H1 is now to sunny, warm, normal, strong because H1 getting the value from X1. X2, yeah, this 2 is obtaining the value from this data set, that is sunny, warm. See, this is a change, so it is replaced by question mark. Then remaining parameters are same. H2, H3 is also same because yes, H3 is a negative example, so no change in hypothesis, so hypothesis remains same. H2 and H3 are same. We'll go for the fourth example where this third parameter, this one, last and the previous one are different, or by question mark. Earlier question mark no need to change. So this is obtaining the value from x4. Now we'll take one more example. Other example you have to solve. There are four attributes. In that, three are the dependent parameter, and one is the dependent parameter, that class, and three are the independent parameter, that is size, color, and shape. Initially, initially three attributes are initialized to 0. This is h1. Sorry, h. Initially h is 0, 0, 0. We'll take the first training example. Small red circle. The first 0 is replaced by small. I'll write only one letter. Second parameter is red, and third parameter is circle because this is a positive example. So no changes in the hypothesis. Let it be h1. Because the second example is no, then skip by retaining the same in h1. h2 is also same. h1 is SRC, a small red circle. h2 no changes at all. Because it's a negative example, this remains the same. Small red and circle. We'll go for the third example. The first attribute is small. Okay, no changes at all. Second is blue, red is changed to blue, so put question mark. Next, circle as it is. So this is H3. The next size is small, you put this by question mark. Second is question mark. Third is circle. So this is, sorry, this is to be ignored because it's a negative example. So H4 is same. H4 is same as the previous one. Small, question mark, and C. And this is also a negative example, so you have to skip. The final answer is small, question mark, and circle. If this is a case, it gives result yes, CL. If you take these two cases, the color is not a matter. That is why it is don't care. The other two should be circle. Other two should be circle and small. So the answer will be, the target concept will be yes. Try this one. You have to solve this. This is solved one. This also you have to solve. The dataset can be created by putting all the values in the Excel file. The first row is the title row, the attribute name and attribute value. So you create Excel file and save this file as your which any name you can use, but the format should be CSV file. It's not ordinary Excel file, it is CSV file. You need to operate on CSV file, import it. In our example, there are six attributes, six independent attributes. Initially, it is null, read CSV file using this statement with open file name, that is read mode as CSV file, reader equal to csv.reader CSV file, scan each row for row in reader, append that row to the A, print it. Well, you can see all the values of CSV file. Next step is our first step, that is putting 0 for all the attributes. There are 6 attributes, 6 times you repeat, you put 0 in the list. So all the values are 0, print them. Next, for j in range 0 to attributes, to the first or this A, that all the data of CSV file there in A, get the first row. First row is this one, zeroth row is the attribute name, that sky, humidity and all that is not required because meaningless. Value only you have to process. Get the second row, actually second row, and that is our hypothesis. As we started with 0, no need to compare, so that first row becomes this one. Then from the second row till the last, you can make this as 2 also, no problem. If the concept is yes, the last attribute, seventh attribute, index value 6, if it is S only, proceed. If the hypothesis value and just now read value, that X are different, you put it by question mark. Otherwise, retain it. For example, if X has got yes and hypothesis has yes, both are compared, provided this is a positive example, both are same, so you just copy, otherwise you can skip pass, no problem. Suppose earlier attribute is yes, now this is y, in this case both are different, that is why you have to replace by question mark, this one. If both are different, general question mark, otherwise retain. So you display everything in the neat format. This is the first row, positive example. In the second case, again second is a positive example. The parameter, that is third parameter, is different. It is normal. Third parameter is different. So replace by question mark. Whenever there is a change, you replace by question mark. Otherwise, you retain it. That's all. That's all about find S. So S stands for specificality. Find S. Find S stands for finding a specific instance which produces all the positive cases. The question mark here it is used to ignore, and the value that is there in the hypothesis, if this is satisfied, it gives the concept or the target value.